Hey guys, Mr. Backward here. In this video we're going to take a look at analyzing functions graphically. So in this first example we're going to look at the graph for the equation y equals x minus 2 squared. And there's a lot of different things that we can talk about with this graph. First thing I want to look at is its increasing and decreasing behavior. As we look at our graph, first we've got a piece of our graph that's going down, and then once we hit an x value of 2, it looks like our graph turns and starts heading up. So what we can say about this graph is it's decreasing on the interval from negative infinity until we hit an x value of 2, and then it's increasing from that x value of 2 all the way out to the right until we hit positive infinity. We can also look at this graph to figure out something about its symmetry, whether it's odd, even, or possibly neither. Remember, even would mean that our graph is symmetric around the y-axis, so what's happening on the right of the y-axis is exactly the same as what's happening on the left of the y-axis, and we don't have y-axis symmetry here. To be odd, that's origin symmetry, so what would be happening up in the upper right quadrant would get rotated down into the bottom left quadrant, and we also don't have odd symmetry, we don't have origin symmetry, so this graph has no symmetry. If we're looking at the shape of our parabola is opening upward, so down at the bottom of our parabola we do have a minimum value. And the coordinates of that minimum point is 2, 0. And one other thing that we should recognize is that this graph is a parabola, so it's very similar to the graph of the equation y equals x squared. Normally our parabola for y equals x squared is centered at the origin, but this one got shifted to the right 2 spaces. In this example, we're going to look at talking about piecewise-defined functions. So I want to look at the function f of x equals the absolute value of x. But I want to look at this function just a little bit differently. Now, a piecewise-defined function is a function that's made up of multiple other functions over specified domains. So we can really think about this absolute value function as kind of a combination of two separate functions. The first function, if we're looking at the absolute value of x, then the first piece would just be f of x is equal to x if the x values that we're plugging in are greater than or equal to 0. Because if we plug in any positive number x for our x value in this absolute value, the answer we get back is just going to be the exact same number that we plugged in. Where we really have to be careful is with negative numbers. So if we have x values that are less than 0, then our function is going to be defined as the opposite of x. So like if we plugged in negative 7 here, the absolute value of negative 7 is positive 7. So we plugged in an x value that was smaller than 0, and the answer we got back was the opposite of that original x value. So a piecewise defined function, like I said, it's just a function that's made up of multiple pieces over specified domains. Now when you start plugging values into a piecewise defined function, the domain will tell you what piece of your function to plug it into. So this top piece says if we're using x values that are greater than or equal to 0, then we plug it into the top piece of the function. But if we're using x values that are less than 0, then we would plug those into the bottom piece of our function. Now in this example, we're going to take a look at that graph that's on the left-hand side of our screen there, and we're going to try to write out a piecewise defined function for this graph. So I'm first looking at the left-hand side, and that first chunk of my graph looks sort of like the left-hand side of a parabola up until we hit that x value of 0. So that's actually how I'm going to start defining my piecewise function. So the left-hand side looks like x squared, and that's for x values that are less than 0. Now on the right-hand side, once we hit 0, this starts to look like a square root graph. So that's how I'm going to define my second piece. And this is for x values on the right-hand side, so that's going to be for x values that are greater than 0. Now there is actually a way for us to type in these piecewise-defined functions on our calculator. So I'm in my y equals screen with my calculator, and I want to type in that first piece, that x squared, for x values that are less than or equal to 0. Now what we're going to do is we're going to take our function that we're typing in and we're going to put it inside of parentheses. So I'm going to go parentheses and then x squared, and then I'm going to close up my parentheses. Now what we have to do to separate the function from the domain that we're going to enter in is hit our division symbol in there, and then we also need to put our domain inside of parentheses as well. So I'm going to open another set of parentheses here. I want x values that are going to be less than or equal to 0. So we need to find our inequality symbols, and right above your math button it says test. So I'm going to go second math to open up that test menu, and we wanted x values that were less than or equal, so we want option number 6 down on the bottom, x values that are less than or equal to 0, and then we close up our parentheses, and then if we hit our graph button, it'll only graph out that left hand side of our parabola until we hit that x value of 0. But we've got another piece of our function to add in here, so I'm going to go back to my y equals screen, and I'm going to arrow down to graph number 2, y2 in here, and this one is the square root of x. So I need to do a set of parentheses, and then do the square root of my x value, and then I need to close up my parentheses there. Again, hit the division symbol to split the function from its domain, and here we want x values that are greater than 0, so I'm going to hit that second math option again. My greater than symbol is option number 3, and then I want 0, and then if I close up that set of parentheses and hit graph, then it'll also graph out the right hand side, that other piece of our function. That's going to be it for this video. Thanks for watching.